Welcome to Java Programming Lessons. My name is Juanita Ahia Kweku. I'll be taking you through today's lesson, which focuses on programming style and documentation. The objective of this lesson is to illustrate how to use programming styles and documentation standards in the creation of your Java programs. Our focus will be to discuss the various types of comment styles and block styles and to differentiate between the various indentation procedures that exist, and also to consider the available naming conventions in relation to the creation of Java. Good programming style and proper documentation make a program easy to read and help programmers prevent errors. Programming styles deals with what programs look like. A program can compile and run properly even if written on only one line, but writing it all on one line would be a bad programming style because it would be hard to read. Documentation is the body of explanatory remarks and comments pertaining to a program. Programming style and documentation are as important as coding. Good programming style and appropriate documentation reduce the chance of errors and make programs easy to read. This session gives general guidelines in doing so. In discussing appropriate comments and comment styles, we'll focus on the various types of comments that exist in the Java language. It is necessary to include a summary at the beginning of a program that explains what a program does, its key features, and any unique techniques it uses. In a long program, you should also include comments that introduce each major step and explain anything that is difficult to read. It is important to make comments concise so that they do not crowd the program or make it difficult to read. In addition to line comments, which begins with // and block comments, which begins with a / and asterisk, Java supports comments of a special type referred to as Javadoc comments. Javadoc comments begin with a / and a * and end with an asterisk and a /. They can be extracted into an HTML file using the JDK's Javadoc command. For more information, consider watching the next lesson in this series. Use Javadoc comments for commenting on an entire class or an entire method. These comments must precede the class or the method header in order to be extracted into a Javadoc HTML file. For commenting on steps inside a method, use line comments. The sample program I'm about to show you displays how to comment in your code. So I'll show you a Java program demonstrating how to type your comments inside your Java file. Okay, so you can see on your screen how the various types of comments we have just discussed can be added to your Java file. So the first one is a single line comment. The second one is the java.comment, comment, and then you can see a multi-line comment or a block comment also here. Right, so let's continue with our lesson. So in the next session, we'll be discussing how to go about the naming conventions. It is necessary to note that every class you create has a purpose and a reason for which you create that program. In that regard, a basic necessity as far as applying naming conventions in Java is concerned is to focus on choosing meaningful and descriptive names. Choosing meaningful and descriptive names. This will help to give you a fair idea the reason why a particular program was created. Aside that, it is also necessary to note that in creating programs in Java, every class you create must begin with a capital letter. Any subsequent words in your Java class identifier should also begin with a capital letter. It is worthy of note that your class names cannot contain spaces. In respect to naming conventions for methods, variables, and other elements of your program, for methods and variables, it is recommended that they begin with a small letter or a lowercase letter, and then any subsequent words that are part of that identifier can begin with a capital letter. You can also decide to use all small letters in assigning identifiers to your methods and your variables. However, if there are more than one word making up the identifier, you can decide to separate them with underscores. In the case of constants, it is preferred that you use all caps in identifying your constants so that they will stand out in the course of your program. We'll move on to the session on proper indentation and spacing. A consistent indentation style makes programs clear and easy to read, debug, and maintain. Indentation is used to illustrate the structural relationships between a program's components or statements. Java can read a program even if all of the statements are on the same long line, but humans find it easier to read and maintain code that is aligned properly. Indent each subcomponent or statement at least two spaces more than the construct within which it is nested, as I'll be showing you in the two sample programs that I have used to demonstrate this style. So our focal point is to identify a good indentation style and then a bad indentation style. So the two programs, good indent style.java and bad indent style.java, will show us how the various indentation principles apply here. So we'll go back and open our files. So the bad indent file, this is how it looks. So you can see that there's no indication of structure or positioning as far as this code is concerned. And then if you check the statement here, you notice that there are no spacing after the binary operator and the other elements used in this computation. Then with a good indent style program, you notice that the program has been clearly spaced out and positioned such that it becomes easier to read and know which section belongs to which part of the program. And that is what I was initially discussing as far as the indentation and spacing of your programs are concerned. We'll move on to the block styles you can use in your code. So there are two major block styles that we'll be concentrating on: the next line block style and then the end of line block style. A block is a group of statements surrounded by braces. There are two popular styles as mentioned earlier: the next line style and the end of line style. The next line style aligns braces vertically and makes programs easy to read, whereas the end of line style saves space and may help avoid some subtle programming errors. Both are acceptable. The choice depends on personal or organizational preference. You should use a block style consistently. Mixing styles is not recommended. For the focus of these lessons, we'll be using the end of line style so that we will be consistent with the Java API source code. So I'll go ahead and show you the two programs demonstrating the block styles we have discussed so far. So we have the end of line block style. So here you can see that the opening curly braces begins on the same line where the class name ends, and then our main method, the opening curly braces, also begins on the same line where the method header is typed. And this is what we mean by the end of line block style. Now let's look at the next line block style. So next line block style, the opening curly braces moves to the next line after your class name. In the same way, it is so with the main method. So the opening curly braces is on the next line after the main method header. We'll do a quick touch up on the various types of errors that can occur in the course of compiling and running your programs. So programming errors are detected by the compiler are referred to as the syntax errors or the compile errors. Syntax errors result from errors in code construction, such as mistyping a keyword, omitting some necessary punctuation, or using an opening brace without a corresponding closing brace. These errors are usually easy to detect because the compiler tells you where they are and what caused them. For example, let me run the show syntax error file to show you the type of errors you can get in relation to syntax errors. So show syntax errors is here. So I open my command prompt and then run the cd documents, and then I'll change to the folder that contains my Java programs, and then I'll compile. Show syntax errors. Alright. Four errors are reported, but the program actually has 2 errors. The keyword void is missing before the main method in line 2, and the string Java programming should be closed with a closing quotation mark in line 3. So if we go back to our code, we'll see that clearly shown. So here you notice that there's no return type for the main method, and then the closing quotation for our string literal is also missing. These are the 2 major errors, and this demonstrates how syntax errors occur. Since a single error will often display many lines of compile errors, it is a good practice to fix errors from the top line and work downwards. Fixing errors that occur earlier in the program may also fix additional errors that occur later. Runtime errors are errors that cause a program to terminate abnormally. They occur while the program is running if the environment detects an operation that is impossible to carry out. Input mistakes typically cause runtime errors. An input error occurs when the program is waiting for the user to enter a value, but the user enters a value that the program cannot handle. For instance, if a program expects to read in a number, but instead the user enters a string, this causes data type errors to occur in the program. Another example of runtime errors is division by 0. This happens when the divisor is 0 for integer divisions. In the show runtime errors.java file, I'll demonstrate how runtime errors occur. So I'll go back to my code. I'll open the runtime errors.java file. We are deliberately doing an integer division where the denominator is 0. So I'll go back to the command prompt, and then I'll run the show runtime errors.java file for us to see the type of errors that okay. So I'll compile, and then in the course of running, we'll see our errors. Okay, so could not find or load. Sorry, I typed the wrong file. Okay, so show runtime errors. Alright, so you see that exception in thread main, arithmetic exception, and the explanation is that we are doing a division by 0. So although in the course of compiling the show runtime errors.java file, we didn't see any error. In the course of running, we saw this exception occurring. So that is how runtime errors behave. Now let's tackle the last type of error, which is logic errors. So with logic errors, they occur when a program does not perform the way it's intended to. Errors of this kind occur for many different reasons. For example, suppose you wrote the program in show logic errors to convert 35 degrees Celsius to a Fahrenheit degree. You will get Fahrenheit 67 degrees, which is wrong. It should be 95.0. In Java, the division for integers is the quotient, that's the fractional part is truncated. To get the correct result, you should use 9.0 divided by 5, which results in 1.8. In general, syntax errors are easy to find and easy to correct because the compiler gives indications as to where the errors came from and why they are wrong. Runtime errors are not difficult to find either, since the reasons and locations for the errors are displayed on the console when the program aborts. Finding logic errors, on the other hand, can be very challenging. In the upcoming lessons, we will learn techniques of tracing programs and finding logic errors. This brings us to the end of our lesson on programming style and documentation. We look forward to you joining us again in the next lesson, where we will demonstrate how to generate your Java doc comments. Thank you.